This is the most famous photograph in modern astronomy. A ring of light with a dark hole at its center, at the heart of our own galaxy. When it was released, it was called the first picture of the black hole we live around. 26,000 light-years away, 4 million times the mass of the Sun, and finally, visibly, there. Except, a team of astrophysicists have now published a model in which that dark center is not a black hole at all, and their version fits the photograph just as well. So what else could be sitting at the center of the Milky Way? Start with what's not in dispute. Something enormously massive sits at the center of our galaxy, and we know that it's there because of how stars behave around it. There's a group of them called the S stars, and they're the fastest moving stars we've ever tracked. They whip around the galactic center at speeds of a few thousand kilometers per second, fast enough to complete an entire orbit in a human lifetime, around an object they never touch. Astronomers followed one of them, called S2, for decades, watching a single star loop around an invisible point, night after night, year after year, until its path could be drawn with precision. And that path told them the mass at the center, about 4 million suns, packed into a region smaller than our own solar system. Nothing we know of can be that heavy and that small and still be ordinary matter. The simplest explanation, the one requiring the fewest new ideas, is a supermassive black hole. That object was named Sagittarius A star. Then, in 2022, the Event Horizon Telescope collaboration did something extraordinary. They linked radio dishes across the entire planet into a single instrument the size of the Earth and pointed it at the galactic center. What came back was that ring, a bright circle of glowing material with a dark region inside it. That dark region is what astronomers call the shadow. The idea is that a black hole's gravity bends light so severely that photons passing close to it are swallowed or swung away, leaving a dark patch surrounded by a bright ring. The image matched what general relativity predicted a black hole should look like. For most people, that settled the question. The black hole had been photographed, and the argument was over. In February 2026, a team led by Valentina Crespi at the Institute of Astrophysics La Plata published a paper in the monthly notices of the Royal Astronomical Society, proposing something different. Their idea is that the center of our galaxy is not a black hole, but a dense concentration of dark matter, specifically dark matter made of fermions, a class of very light subatomic particles. Here's what makes their version interesting rather than idle. Dark matter of this kind would not simply sit there in a clump. It would naturally arrange itself into two connected parts. An extremely dense, compact core at the very center, wrapped in a vast, diffuse halo spreading out across the whole galaxy. Core and halo, one continuous substance. And the core would be concentrated enough to bend space-time almost exactly the same way 4 million solar masses of black hole would. So they tested it against the hardest evidence available, the orbits of the S stars. When they modeled S2's path around a fermionic dark matter core instead of a black hole, the orbit came out almost indistinguishable from the one we actually observe. The same model also reproduces the rotation of the galaxy's outer regions, hundreds of thousands of light-years away, using the same substance. And a separate study had already shown that when an accretion disk lights up a dense dark matter core like this, it casts a shadow with a bright ring around it, strikingly similar to the EHT image. As one of the authors, Carlos Arguelles, put it, They're not simply swapping the black hole for a different dark object. They're proposing that the supermassive thing at the center and the galaxy's dark matter halo are two expressions of the same continuous substance. That is the part that makes physicists look twice. Right now, we treat those as separate problems. The black hole is one field of study. The dark matter halo is another. This model tries to close them into one. There's also a loose thread it addresses. A gas cloud called G2 passed close to the galactic center, and after its closest approach, it was moving more slowly than a simple orbit around a black hole predicts. The usual fix is to say something dragged on it. A dark matter core changes the shape of the gravitational well, and the discrepancy becomes less awkward. Now the part that matters if you want the truth rather than the headline. This is a minority position. The overwhelming majority of astrophysicists still think Sagittarius A star is a supermassive black hole, and they have a good reason to. Black holes are a direct consequence of general relativity, a theory that's passed every test we've thrown at it for a century. Fermionic dark matter of the specific kind this model needs has never been detected. The black hole explanation requires no new particles at all. What this paper actually demonstrates is narrower and more interesting than it's not a black hole. It shows that our current observations are not precise enough to rule the alternatives out. Both models fit the data we have. That's not the same as both being equally likely. But it does mean the case is not as closed as that famous photograph made it feel. And there's a way to settle it. General relativity makes a very specific prediction about a real black hole. Close to the event horizon, light can be bent so severely that it orbits the object before escaping. That creates a thin, sharp feature called a photon ring, a hairline of light produced by photons that looped around the black hole on their way to us. It exists because there's an event horizon. A dark matter core, however dense, has no event horizon, so it cannot produce one. That makes the photon ring the deciding instrument. Find it and the black hole wins outright. Keep failing to find it as the instruments sharpen and the alternative gets harder to dismiss. One group has already claimed to detect it, and that claim was heavily criticized by other researchers, which tells you exactly how close to the edge of our capability this is. The next generation of Event Horizon Telescope observations is aimed squarely at this question. So here's where it leaves us. There's something at the center of the Milky Way with the mass of 4 million suns, and we photographed the darkness where it sits. It is almost certainly a black hole, but almost is doing the real work in that sentence, because a model made of dark matter fits the same stars, the same rotation, and the same photograph, and we do not yet have the precision to tell them apart. The most famous image in astronomy is still, quietly, an open question. This channel is about exactly these moments. The ones where something everyone treats as settled is still being argued over. If you want to be here when the measurement lands, subscribe and stick around. Until next time, clear skies.